this video we are going to learn tangent plane of the sphere. Okay, so we will learn what is the equation of tangent plane of the sphere and one example based on this tangent plane of the sphere. Okay, so consider the sphere having center minus u minus v minus w, and point P is any point which lies on the sphere as well as on the plane. Okay, now let the general form of the given sphere is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. Okay, now the DRS of line CP, okay, you can see here line CP, one coordinate, one end point is center of the sphere, that is minus u minus v minus w, and other end point is a P, that point P lies on the plane. Okay, now the DRS of this line CP are, you have to just subtract coordinate wise, x1 minus of minus this u, that is x1 plus u, and therefore the DRS of line CP are x1 plus u, y1 plus v, z1 plus w. Okay, we know that the equation of plane passing through point x1 y1 z1 is given by a times x minus x1 plus b times y minus y1 plus c times z minus z1. Okay, so let us call this equation as a equation number 1. Okay, where a b c are DRS of normal to the plane. Okay, you can see here the line CP is actually normal to this plane. Okay, now let us we already found the DRS of this line, that is DRS of this normal, which are, you can see here, x1 plus u, y1 plus v, z1 plus w, and therefore the values of ABC are x1 plus u, y1 plus v, z1 plus w, and substituting these values in equation 1 we get x1 plus u in bracket x minus x1 plus y1 plus v in bracket y minus y1 plus z1 plus w, z minus z1 is equal to 0, and which gives, or which is called as equation of tangent plane to this sphere. Now let us take one example. Show that the plane 2x minus 2y plus z plus 12 is equal to 0 touches the sphere x square plus y square plus z square minus 2x minus 4y plus 2z minus 3 equal to 0, and also find point of contact. Okay, so we have to show this plane is a tangent to this sphere. It touches to the sphere, that means it is tangent plane. Okay, so what is the key point here? Look at in the diagram. If suppose this is a sphere and if this is a plane that it touching to the sphere, that means this distance of line CP must be equal to radius of this sphere. That is the key point here. Okay, so let us find out radius of this sphere and the distance of line CP. Okay, if both are equal, that means this plane touching to the sphere. Okay, so we know that if the plane is a tangential to the sphere, then the length of perpendicular, that means length of this normal from the center of the sphere on the plane is equal to radius of that sphere. Okay, as I told you already. So given that equation of sphere is x square plus y square plus z square minus 2x minus 4y plus 2z minus 3 equal to 0. Comparing with the general form, this is the general form of the sphere. So comparing with the general form, we get 2u is equal to minus 2, 2v is equal to minus 4, 2w is equal to 2, and d is equal to minus 3. And therefore, we obtain the values of u, v, w and d. You can see here. Therefore, center is minus u minus v minus w, that is 1, 2, minus 1. Okay, that is the center. And radius is square root of u square plus v square plus w square minus d. So after putting these values and after computation, we get r is equal to 3. So we have found the radius of that sphere. Now let us find out the length of this CP. Okay, so we know this formula that length of this CP, that is length of this normal to the plane, is given by a times x1 plus b times y1 plus c times z1 plus d divided by square root of a square plus b square plus c square. So we already know the values of x1, y1, z1, that is 1, 2, minus 1, and ABC are DRS to the DRS of normal to the plane. Okay, this is the plane, then ABC represents DRS of normal to the plane. So the equation of given plane is 2x minus 2y plus z plus 12 is equal to 0. That means this coefficient of x, y, z represents DRS. Okay, ABC, and therefore the values of ABC are 2, minus 2 and 1, and the center is x1, y1, z1 is equal to 1, 2, minus 1. So after substituting these both the values in this formula, we get CP is equal to, do the calculation. So after calculation we get CP is equal to 3, and that means CP is equal to 3, and also radius we already found, it is also 3, and therefore both are equal, and that means the given plane touches the sphere. Okay, next our aim is to find out point of contact. Okay, so the to find point of contact, that means we have to find the equation of this line. So accordingly we can find out point of contact. Okay, so DRS of line CPR, we already found the DRS of this line CP. It is they are 2, -2, 1, because DRS of normal. Okay, DRS of line this CP means DRS of normal. Okay, and also it passes through one point, that is center. It passes through point 1, 2, -1. Okay, so this line end point of this line is a 1, 2, -1, and that means it passes, or the end point of this line is this center. Okay, so the equation of line CP through this point and having DRS 2, -2, 1 is x minus 1, that is x minus 1 divided by this DRS first, 2, y minus 2 divided by -2, z minus minus become +1 divided by 1 is equal to k, say. Okay, so therefore the values of x in terms of k, values of y in terms of k, and values of z in terms of k, and therefore is the any point that lies on the line. Okay, note that CP touches the plane at point P. You can see here CP touches the plane at point P, and this point is any arbitrary point now. So for because the k is a parameter. Okay, so we substitute this value xyz in the equation of the plane. Okay, so substituting this value in the equation of plane, that is 2x minus 2y plus z plus 12 is equal to 0, we get 2 times 2k plus 1 minus 2 times minus 2k plus 2 plus k minus 1 plus 12 is equal to 0, and solve this expression for k. So after solving we get k is equal to -1, and substituting this value k is equal to -1 back to this expression 2k plus 1 to minus 2k plus 2 minus comma k minus 1, we get it is -1 minus -1 4 -2, which is the required point of contact. Okay, I hope you understood this.